Right, so welcome to the second longest titled talk at scale. I lost to Hetty. So recovering from data loss despite not having a backup, a Postgres true story. My name is Jimmy Angelakos. A little bit about me. It's my first time at scale. I identify as a systems and database architect. I'm based in Edinburgh, Scotland, but I'm originally Greek. I have been using open source for over 25 years, and I try to contribute to projects where I can. One of those projects is Postgres. I have been using Postgres exclusively as a database for more than 16 years now. I'm writing a book called PostgreSQL Mistakes and How to Avoid Them. And I have co-written a book, which is the PostgreSQL 16 Administration Cookbook with some other brilliant fellows. And I have also written a Postgres extension for performing time series analysis of Postgres internal statistics and plotting them into charts, which is called PGStatViz. So, back to the title of the talk, Recovering from Data Loss Despite Not Having a Backup. What? That's right. The company had no backup. It was a real company. You're not going to see screenshots from the actual procedure because I don't have permission to share that, and it's been more than a year, so it's based on my recollection of this odyssey. But it was an actual company with customers that lost their entire database. And these things happen more often than you would think. So let's set the scene. The phone rings on a Friday evening at 5 p.m. Everyone's ready to go home. I was at home because I work from home, so no change there. And maybe it wasn't the phone, maybe it was Zoom, because nobody uses phones anymore, especially for business. But the gist of it is, the CTO of the company comes on the call, and he sounds extremely tired. And he says that they lost all their data, and he says they have no backup. At that point, I'm ready to commiserate him, and then he asks, can we recover the data? So I say no. That's it. Thank you. No. No, wait. So I said, let's figure this out. What's happening? First of all, the database that they lost was critical to their operation. The company cannot work without this database because their website is the database. It's the contents of the database. The service they provide is all in the database. Their website, I find out on the call, has been down for more than a week. And there's a page that says, we're sorry, we're having technical difficulties, and no information at all for more than a week. And their users are starting to complain because a week's fine, but more than a week, that's an outrage. Which also means that if the users are starting to grumble, their stakeholders are starting to worry as well. The people that run the company, the people who invest in the company, they're starting to worry. So what happened? They had a disk crash that wiped out their production database server. And you may think, okay, it was just one server with no redundancy. So their Postgres is gone, gonzo. Their most recent backup that they did have is months old. So they really can't use it for the kind of service they provide because it relies on the recency of the data. It needs to be up to date. They get a quote from a database recovery company, and they said, we'll see what we can do in 2 weeks. No guarantees. It's going to take 2 weeks, but we don't know if we'll be able to recover the data. So how does one find themselves in this situation? The company used to be a startup, and they grew in size and customers and importance over time. And they transitioned to Postgres from a less serious database decades ago. So they know Postgres. They've been using Postgres for a long time. But they were using pgdump for their backups. pgdump is not a backup tool. It can complement a backup tool or be used as a backup in an emergency, but it's not a backup tool. Because it doesn't do anything on its own. You need to script something which will use pgdump to take a backup. And unfortunately, the lovely script that they had over the past 20 years or so had started silently failing. And there's all these things that can go wrong without you noticing when you move things around. So you may think, oh, I'll just take this here server and put it on the cloud or put it in a Kubernetes pod or something. And one of the scripts doesn't like the new environment, the very reliable script that you've used for years and years, and suddenly there's no error message, nothing, and it's been silently failing. So that's why their last usable backup, in quotes, was months old. And I'm thinking, is this really bad luck? Were they unlucky? We know that hardware fails. It is not uncommon. But there's a glimmer of hope. Not the database recovery company, but a data recovery company has looked at the hard drive, and they have managed to recover some files. It looks like the physical disk is not damaged, and it was probably a controller failure, and that's why they recovered the files. So the company gives me the dump of the recovered files in order to see if we can construct a database out of those files. But they give me files that are randomly distributed in recovery directories that are named 0001, 0002 to 100 plus. And I'm looking inside these folders, and I don't see any structure. It's just files jumbled. And they're not in the folder where, well, we've lost the folder names, right? So, but also the files look like they belong to different directories on disk, so they shouldn't be together. So there's no guarantee that the files in 001 belong in the same directory. Why is this bad? You have to consider how Postgres stores things on disk. Let's look at that for a little bit. So the physical structure of a Postgres database on disk, and if you assume that you're using Red Hat or a Red Hat-like system, it will probably be under var lib PostgreSQL, the version of Postgres Especially if you're using the community packages, this is where you're going to find your Postgres database. And when you perform an ls on this directory, you see things like global confd, some configuration files, and you also see a directory called base. This is the one that holds your data mostly. So your tables, your indexes, they're going to be in base. Why is it called base? Haha, it's data/base, so that's where the database is. So the base directory contains subdirectories that hold individual databases. The name of these directories is the OID, or object identifier, that identifies that database in the Postgres catalog. So they're going to be incomprehensible names to you. So if you have a database called Jimmy, you won't find anything on the disk that's called Jimmy. You will see things like 1, 16,582, 16,587, 4, 5, and PGSQL TMP for temporary files. So we mentioned the Postgres catalog. So there's a view called PG database that you can select from the catalog. And if you select object ID 16,587, that is an identifier that we saw on disk for one of the databases. So select star from PG database where OID is this, and you get OID, the database name finally, and you find out that that database is called PG Bench, which is the example I'm going to use in these slides. And other things such as the owner of the database and coding and so on. As we mentioned, each of these directories, subdirectories of base, contains the tables and the indexes for these individual databases. How do you find which file belongs to which table? By selecting the table name or relation name and object identifier of the table, and rel file node, so relation file node, is the file name for the identifier for the file that holds the table from PG class, where the table name is PG bench accounts. You can find out how it's stored on disk and which files it's using. And you can see that the table PG bench accounts that has OID 16,594 is stored in rel file node 16,600. So what does that tell you? That tells you that unlike databases, tables, their OID may not match their rel file node. So you can have a table that has in the Postgres catalog OID 16,000 something, and you can have a different rel file node for that table. And you will also find some other files on disk, such as the FSM and VM, which is the free space map for the table, and the visibility map, and other useful things. And that's how it works for indexes as well. They have their own individual files on disk. Now, Postgres has something called the segment size. And the segment is how big a file can be on disk before they need a second file. So tables that are more than 1 gigabyte, because the default segment size in Postgres is 1 gigabyte, they get split into multiple files. And what you see on disk is one file that's 1 gigabyte, and then the next file that it spills over into is called .1. And if there's another gigabyte, then there's the third file called .2 and so on. So you can see how your table can keep growing without any restrictions apart from disk space. OK, so that's how Postgres puts files on disk. So what is the recovery plan, if any? The recovery plan is to recreate the data directory structure that we just saw for their lost database with the files that we got from the recovery operation. So we basically copy the files inside the directory where we believe they should be. So the next step will be, after we've copied the files, we try to start Postgres with the folder that we put the structure in, which we will call opt recovery. And if Postgres starts, then we will attempt to perform a PG dump, to perform a logical dump of the database, so that we can ensure that everything can be read correctly from disk. Because if there's any corruption, then PG dump will stop, and it will say, I can't read this file, I can't read this index, and so on. So after we have the dump of the data, the plan is to restore the dump to a fresh database. We really shouldn't trust this directory anymore. We should extract the data from it and try to start anew from a fresh server. Next step, question marks, profit. So how do we copy the files inside the data directory? It looks scary. It's all numbers. There's things like 112, 113, 1200. And if there's hundreds of tables, it looks daunting. But the reality of it is that OIDs below 16,384 are reserved for system use. So they're probably not the tables, they're certainly not the tables of their database. So I can focus on the ones that are over 1,600 first. Yes?
So the data recovery company managed to restore the file names, just not the
Yes. Fortunately, the file names were saved, but there was no structure to the file system. It was just a dump of files. So I can skip most of these things because they might be common across databases and parts of Postgres default tables and views. So after a lot of typing and copying files back and forth, we need to see if Postgres will start. So the first attempt is we use pgctl to start Postgres, and we pass the parameter d for the data directory, and I say, try to start the Postgres server from this data directory, which is opt recovery. So it says waiting for server to start. Stopped waiting, could not start server. Examine the log output. That was not unexpected, right? Let's see what the log says when we examine it. So the log says, fatal error, could not access the status of transaction 803. Could not open a file called pgexact/0000. No such file or directory. Well, that's a problem. It means that the file, either we didn't find the file in the dump, or it wasn't recovered. So I start looking for these files, and I can't find them in the dump. And it's obvious that Postgres won't start if that file is not there. Why? It says aborting startup because of this failure, the database is shut down. So what is PG exact? And what is this 000 file? It holds transaction commit state for each transaction on disk. So these are files that are usually 256K in size, and they store data on the transaction outcome, whether it was committed or aborted, etc., in a weird format, which stores the outcome of 4 transactions per byte. So it's 2 bits per transaction state. What we want, because now I've decided to fake this file since we don't have it, right? We want status 01, which is committed for all transactions referred to in that file. So we need to fill it with 01010101 for each byte for these 4 transactions. And the way to do it easily is DD. So you create a file with 256K of zeros, but we actually translate the zeros to octal 125, which gives us 01010101. And we fill the whole 256K with 01. Straightforward. So we put the file there, and does Postgres start now? Well, originally it didn't, and then it complained that 0001 was missing, and then 0002. So I had to fake all these files, and finally, Postgres started at some point. And it said, waiting for server to start, done, server started. I'm stunned that this collection of files on disk appears to think it's a working database. Can we connect to the server? So I try PSQL. The default to PSQL is it tries to connect to database Postgres as user Postgres. As the current user. But I was logged in as Postgres. So connection failed, fatal, database Postgres does not exist. That is not good. But it tells me why it thinks that the database doesn't exist. And it says that the database subdirectory base/5 is missing. I'm like, oh, OK. So I need to find this. I need to recreate this directory, 5, which is the OID of the Postgres database. And I need to fill it with files. So I find the files for the directory 5. Clickety-clack. Does Postgres start now? Yes. Postgres starts. And I am starting to become hopeful at this point. So let's say that we want to connect to database PG bench to see what's in there. So connect PG bench, fatal. Database PG bench doesn't exist. The database subdirectory is missing. But now I know the OID. And I know which directory to recreate and put the table files and index files, et cetera, that I found inside this directory. Some more typing, and I can connect to PG bench after I've created the directory and copied the files in there. So what follows next? The next step is to perform the PG dump. So let's do it. People are waiting, right? This is taking course over 8-hour days on Saturday and Sunday. I said, I can't work more than 8 hours a day, but I will help you. So, but they're waiting. They haven't slept in days, right? They're waiting for news. So I try a PG dump of database PG bench into the file pgbench.dump. And it works. At this point, I am ecstatic. I call them immediately and I say, I have a dump of your data. I don't know how corrupt it is, but I have a dump of your data. Are we done? Is the recovery complete? No. We need to take this dump and restore it into an empty database server to see what we get. So restoring the dump is pretty simple. You just call PSQL. You create an empty database called pgbench, and you pass it to the file pgbench.dump. It's an SQL text format file, so it just runs SQL commands to populate, to recreate the schema and populate the database. So I get error could not create unique index from a table. And it says this key is duplicated. Now that is weird, but not really if you consider what we did. So what we did was we said every transaction was committed when we faked those files that were missing that we needed in order to start the server. So some rows that were dead have now been resurrected. And we need to figure out what the current version of the row is so we can get rid of the duplicate that has the same or different data. So that repeated itself for about 100 times, and I had to go to the customer and ask them, you know, I have this customer account that has this data and then this customer account. And they said, yeah, that's more recent. So I did that about 100 times, and they confirmed which row we could keep. Fortunately, it seemed to be only a few tables that had this issue. And it was only like 100 times, so it didn't take more than a few hours to work through. So in the end, this was a dramatic save for them. We completed the restore, and they had a working database with data that appeared to be correct and intact, verified by them, by Sunday afternoon, which was less than 48 hours after they got in touch. Meanwhile, their stakeholders were holding a conference call, and they were deciding whether to pull the plug on the company. If they lost this data, it would have been an extinction event for the company. They would have had to work very, very hard to regain the trust of all their customers that they lost the data for, right? So the stakeholders are in a conference call. The CTO jumps in on the call and says, we've recovered the data. So applause breaks out on the call. Everyone is relieved because they knew that someone was working on this for the past couple of days, but before then, they hadn't seen any evidence that the data was actually recoverable. So they're really relieved. But I'm not relieved because I can't relax until we create a backup of this database that they can actually use, because for all I know, their disk might fail in the next 5 minutes, and we might have to go through all of this again. So I say, okay, tell your stakeholders, but I'm taking a backup this moment. So I create a streaming replica of the server immediately, and I set it up with Rep Manager so that they can fail over. And I set up backups immediately again with Barman is the tool that I used. And then, after I had these things in place, I said I can now relax, and it's time for a beer. So what is the final analysis for this adventure? They were extremely lucky, because most of their files were recoverable, but they were also lucky that Postgres has such a clean structure. I was able to describe to you, so even if you weren't familiar with Postgres internals, someone can spend like 30 minutes explaining to you how files are put on disk, and that gives you an understanding of this cryptic directory with numbers in it, right? So it's not black magic. There's a logic behind all of this, and this is why we were able to recover their data. It wasn't just one binary blob on disk. It was a collection of files, and as you pointed out, fortunately they had the file names, so we could attempt to reconstruct. It took a few iterations, but eventually we got there. So even if you've lost some of the files, you can use this methodology to recover as much of your database as is recoverable. Save whatever can be saved. And you can also fake files or reconstruct them correctly. Files such as pgfilenode.map or pgcontrol, you can recreate those, or you can fake those, or you can take them from a running database and they will be the same. So the good thing is that Postgres complains at startup that this file is missing. So it doesn't say error, I'm throwing my hands up, I don't know what's wrong, right? It tells you what's wrong. And this is why we were able to identify the files that were causing the problem because they were missing and so on. If the file that holds the data for the table is gone, then the table is gone. But you can attempt to recover the other tables, right? You can just remove that table from the catalog and proceed. Or you can dump each table individually, right? You don't have to perform a full PG dump of the database. Now, what about the write-ahead log that is in PG wall? That wasn't that important for this recovery, because whatever was in there is going to be used to recover to the last feasible point when the server starts up. So whatever you have is whatever you have. If you've lost some files from wall, they just won't get replayed. And you may have lost the last, let's say, 16 megabytes of transactions. I think that's acceptable compared to losing your entire database. So let's see what you should not do so that you can avoid finding yourself in this situation. First of all, you should not use pgdump as a backup. I mentioned in the other talk by Magnus, he said that the same thing. He said pgdump is not a backup, and I told him, then we should change our documentation. Because as someone pointed out to me a few weeks ago, when I told him that pgdump is not a backup, he said, your documentation says that it is a utility that you can use for backing up Postgres. So we probably need to send a documentation patch, which will get scrutinized and rejected. But we need to tell people that pgdump is not suitable as a backup tool, because it doesn't support point-in-time recovery, the thing that wall is there for, right? So when you have a pgdump, it only captures that moment in time. You cannot roll back, you cannot recover up to a certain point. It's a snapshot, essentially, of the database. Plus, as a backup tool, it is sorely lacking because it doesn't have automation. For me, if your backup is not automated, it's not a backup, right? Manual backups are not backups because you may need to go to the dentist, or you may have something to do and forget about it, or someone else forgets to take the backup. It needs to be automated. It needs to be monitored so that you know if the backup is failed. There needs to be alerting to notify someone, you know, you have no backups. You need to run and take a backup now, because we'll lose data if something happens now. And of course, backups need to be tested, because as GitLab found out a few years ago, they had a backup, they hadn't tested it, and so they lost a lot of data. So in order to avoid doing all this, you can just use one of the ready-made backup tools that exist for Postgres, like PG Backrest or Barman, the two open source tools that dominate the field. There are also proprietary solutions that you can use. I know that some of them work with Postgres now. So really, this should come as no surprise. You should not use pgdump as a backup. And what you should also not do is maintain radio silence, because the people that need to use the database will start coming up with theories. This is real. They came up immediately with a theory that the database was unrecoverable, that it was ransomware, that some hacker broke into the database, and that's why the company is not saying anything. The company was not saying anything because they didn't know, right? When they found out that the files could be recovered, they shared that with their customers. When I told them that I now have a dump that we can attempt to recreate, they shared that with their customers. And when I told them that the database is up and running, they immediately shared that with them. You need to keep everyone informed, otherwise you can suffer reputational damage, which sometimes is worse than the actual damage of the data loss. Right, so it wasn't a security breach, it was just one of those things that happens. A disk went boom, and what you should do in that situation is not to panic. You don't start running around waving your hands in the air saying, oh my God, what are we going to do? Inform the president, inform everyone. You need to think rationally and examine the situation, see what you do have, see what you don't have, and see whether that can lead to a successful recovery. What you should do in order not to find yourself in that position is have redundancy. Streaming replicas are dead easy to set up. Even if your server goes boom, if you have a streaming replica, you can just start using that immediately. You should have automated tested backups, as we said. When you do recover the data, don't touch them. Make a copy of the recovered files and operate on the recovered files. And as we said, you need to keep the team informed. So even if you're the database person that is attempting to stay in front of a screen for hours and hours trying to recover the data, you need to keep the stakeholders informed with what you're doing. So another thing that we can learn from this is that the degree of recovery, how much data you recover, matters, but also the speed matters as well. That's why we took the decision, me and the company stakeholders, we decided to fake the transaction IDs to proceed. It would have taken a very long time to figure out the correct outcome of every transaction, right? So in the end, it was faster to just fake the files, pretend that all the transactions were successful, and deal with a few duplicates. It's better to bring something out faster rather than wait for complete correctness sometimes. But of course, that is not a decision that I should make, right? You should, as a tech person, you should always ask the customer what they want to do, because what may be obvious to them may not be obvious to us, right? They have business requirements. They say, this table matters, recover this table only, or recover this table first. Thank you very much. Any questions? There's one.
Kind of curious. For the recording.
Yeah.
Can you hear me? It's on. Okay. So, just out of curiosity, at no point did I hear you. It could have been in the clickety-clackety, but did you not use the backup, the months-old backup, to simulate the file structure or the table, like to try and identify?
There was no file structure. It
No.
was a logical dump, so it was SQL commands.
Oh.
So I couldn't use that. So the PG dump that they took, well, every PG dump is a logical dump, but it doesn't store any of the structure of the database. It just stores the data and the schema as SQL. And sometimes it puts it in a binary format, but they only had the text format.
I was wondering if you had any any thoughts or ideas on like whether there's any room for Postgres core to build out something to protect, I guess, users of Postgres from themselves in this case, or kind of like, is there some strategy that might at least help avoid this failure mode of like we don't know what we don't know, like we don't know that our backups aren't really working, like I don't know, like a really silly thing that probably isn't very useful that I just thought up is like, what if Postgres just like refused to start or
Right.
with an error if you don't have an archive command set or some things pertaining, at least as far as Postgres has visibility onto it, some things that pertain to backups, like Postgres will just say, okay, well, you can set some other GUC saying like,
Right.
I don't care about my data, this is just a test DB with underscores or camel case or whatever, and then I'll start up. But I don't know if you have any thoughts, like maybe not that specifically.
Yeah, so
but in
Postgres
general.
leans on the side of letting the user decide what to do instead of telling them you should do this, which gives you more freedom and becomes less annoying because, as you said, you may have a test database that you don't want to back up. You don't want Postgres complaining, oh, you don't have backups for this database, right? So what Postgres tends to do is let you shoot yourself in the foot. And also, there is no official backup tool for Postgres in core, intentionally, because everyone else has the freedom to develop what they like. So there's PG Backrest has focused on different areas of the backup procedure than, let's say, Barman or Wally or WalG, right? There's all these solutions that you're free to use, and Postgres doesn't make you use any of them. Now, archive command is not used by most of these tools, so you wouldn't get a warning anyway. So Postgres does warn you when there's something preventing it to start up, but it doesn't warn you against things that you should know, such as take a backup. Yes?
Are they at least using a RAID system on their new server?
I don't know that. I remember we restored onto some cloud instance, so I guess that's taken care of. But it wasn't really my job to tell them what to do. I told them what to do for not getting in this situation again in the future. I can't tell them where to run their databases or which provider to use or what hardware to use, but I could tell them that you really should have a backup, you should test it, you should have redundancy and so on. And that's why I ensured before I left for the day that I created those, because if I said, well, you need to do those things and didn't check to see if they did them, they probably wouldn't, given their track record.
What percentage of their weekly expected revenue did you charge for your 48 hours of work?
Let's say I got something out of this. It wasn't my engagement. I was working for a company that said, it's up to you if you want to work during the weekend or we can tell them that we'll start work on this on Monday. So I took the decision because I felt sorry for them, really. When they told me that their database had been down for a week, I saw that this company was in deep trouble, and I tried to help them. It's not really about, well, at that point, it wasn't about money for me because I would make the same amount of money whether I helped them on a Saturday or a Monday or wherever. But,
Okay, any more questions?
great, thanks very much.
Thank you, Jimmy.